Welcome to Math on the Fritz with me, Mr. Fitz. Today we're going to be looking at polynomials. And if you're looking at a polynomial, you see that there's going to be more than one name that's used. So if I just put up a polynomial, 5 plus 8x squared minus 3x cubed, you can see that there's three separate components that are going on in this particular polynomial. So if I were trying to talk about this, since there's three unique parts, I would call it a trinomial. Just the same way you'd have a bicycle or a tricycle. Bi has 2 wheels, tricycle has 3 wheels. It's the same thing here. This is a trinomial because it has 3 pieces. But it's not really in order. I want to get these things in a certain order. Mathematicians are very specific. And where you're going to see this in life is with a cash box. I don't know if any of you out there have seen cash boxes when you buy things at the store, but if you just chuck all of your money in a giant pile and throw it in a register, it's going to be really hard to keep track of. You're going to lose track of what you actually have. So when we do our polynomials, we like to line it up in a certain order, the same way that you would line up a cash box. So I conveniently have a donated cash box here from our school's JMG department. And you're going to see, if you look at the inner side of that cash box, it has different slots that you use to put all of your money in. So instead of just piling the numbers in any random order, you put all of your big bills here and you work your way down to your smallest bills. Same thing with the coins. You usually have a coin tray where you can do coins. We do the same thing in math. We start with our biggest bills and we work our way down. So when I look at this, when I say biggest bill, I don't care about the coefficients out front or the numbers. What I care about are these exponents. These exponents tell me how big the number is. So when I look at this number, -3 is the smallest number in the list, but its exponent is the largest number. So this would be considered the highest valued slot in my polynomial. So I'm going to list this one first because it has the highest exponent. We call that the degree. This has a degree of 3. X squared, 2 is my next highest exponent, so I'm going to list that term second. And then the last term is my constant. There's no variable at all. It's just a number. So I'm going to list that one at the end. Now I have my number in a perfect order. This is how a polynomial should be written. This is called descending order. And it's called descending because it's going down from the highest power of 3 to the lowest power, which is technically 0. So we have this great setup. They're all in order and they're sorted out. So now we get to the next part of a polynomial, which is, well, what happens if I have 2 polynomials and I'm trying to put them together? So if I take this last part that I had here, and I write it in order, this is what I'm going to have. I'm going to have -3x cubed. I'm going to have plus 8x squared. I'm going to have my plus 5. But what I'm going to do is I'm going to add another thing to that, another number. We're just going to see what happens with it. I'm going to do -4x squared. And then I'm going to do plus 3x, and then I'm going to do minus 6. And we're going to see what happens when I try to put this together. Now, remember that cash box that I was talking about. We want to be able to use that kind of as a visual to see what's going on. So if I bring the cash box back and I kind of show you those numbers, I'll bring it nice and close to the camera so you can see them. You're going to notice I've already sorted out, I want my highest power on the left, and I want to work my way across to each place. So if I have 2 of the same number, like here I have an 8x squared and I have a -4x squared, that would be like 2 bills of the same amount going into that cash drawer. So they're both x squared, so I put them in the same drawer. And then I see that I have a 5 and a -6. Those are both constants. So I'm going to take my 5, and I'm going to take my -6, and I'm going to put them both in that same cash drawer. but I only have one x to the third. There's no other x to the third. So that's all by itself in the cash drawer. Now you're going to notice I included the negative here. The math has no way to tell if it's plus or minus in between. So I'm including the negative with the 3 when it goes into my x cubed cash drawer. And then the last one that I have left that I haven't used is x. So I'm going to take that one. It's like it's going in its own cash drawer. So I've sorted them all out now in order of the power. So I only had one thing. If I pull it out, I only had one item in my x cubed cash box, so I keep it. Negative 3x cubed. Negative 3x cubed. Now I take a look in my x squared. I had two values that were x squared. I had my 8x squared, and I had my negative 4x squared. So I have to put those together now. At the end, I'm going to tally up my cash box. I end up with positive 4 in my x squared slot. Now I look to my x slot, my next largest remaining power. There's only one item in there. It's a plus 3x. And then I go to my final cash drawer, which is the constants. I have a positive 5 and a negative 6. When I add those together, I get negative 1. And now I have everything in order based on power. My highest power is a 3, and working my way down all the way to the constant. And this is how you simplify. This is how you put together two polynomial expressions. So those are some of the key words you're going to see in this unit. Those are the concepts. We're going to be talking a lot about the degree, which is based on the exponent. And you're going to realize that when you have two things that are raised to the same power and you're adding them together, you're just combining the coefficients out front. The same way you would in a cash drawer when you tally everything up, you sort it out, and then you tally it up. And that's how we determine the answer for all of these types of questions.